Before I start, I'm just going to say one or two things about Johnson Controls, who I work for. So they're sponsoring tonight's event. We're just based down in Albert Quay. I don't know if you know the building. It's the new one next to City Hall. So Johnson Controls, we're a smart building, HVAC, fire safety and security company. Specifically in Cork, we do IoT. So we're building kind of like the next generation of devices, cloud systems, just to try and get everything to talk to everything, to secure buildings, to secure premises, and to secure people, firefighters, and so on. And right now we're hiring. So if you're a software engineer and you're interested, just have a look at the website. There's a section, Careers Cork, and you'll see it all there. So I know typically this is a JavaScript event. Is that right? Not right? No? Bit of everything? Okay, so there's no JavaScript. Okay. So I'm going to talk today about how to build an analytics dashboard in 150 lines of code, which is ambitious. And I'm going to do that with Docker, InfluxDB, and Grafana. So I know that maybe not everybody has heard of those things, and that might be initially something that will terrify absolutely everybody here, myself included. And you're like, what is all this that he's talking about, all these buzzwords that I've never heard of? So maybe, has everybody heard of Docker? Yeah? Okay, good. Right, so I'm going to start out by talking about Docker. You can maybe skip some of the easier bits. So Docker basically looks like this. So if you're used to virtual machines, Docker is a kind of a similar concept. The way it works is with a virtual machine, you've got some hardware infrastructure, you've got an operating system, you've got your hypervisor layer, and then on top of that, you layer your guest operating system. So this could be something like Windows, it could be something like Linux, and then on top of that, you're going to install your bins, your binaries, your libraries, and then finally on top of the very, very tip-top layer there, you're going to have your application, whatever that might be. And that sucks for a whole load of reasons. And what Docker aims to do, in some senses, is to kind of fix that, okay? And so the way that this works basically is it's the same kind of stack at the start. So you start with your infrastructure, you have your host operating system, and then instead of a hypervisor layer, you've got the Docker engine. And what this does basically is it tries to bridge your bins and libs, your binaries and your libraries, directly into your host operating system. It tries to bridge that gap so you don't have to run a hypervisor. You can just, your application, when you run it, it talks to the host operating system running down here, okay? And then, so in principle, this should mean that your applications are faster. In practice, they use less memory. They're easier to maintain because you don't have to run multiple guest operating systems just to run your application. You can just run your application directly on the kernel. So containers, the whole idea is that Docker works on something called a container. And a container bundles everything that an application needs to run. So that might include your code. It could include things like configuration scripts or your graphics files, system libraries, like some jars, node modules, Python packages, and other things like Git, maybe Gradle, libc if you want to do any compilation. And the idea then is that if you put all your stuff into a container, when you deploy it using a container engine, Docker is only one engine for containers, but if you deploy your container using a container engine, it guarantees, sort of, that the container will run the same way regardless of where you put it. So the idea is that you could have a standardized build environment, so that might be good for developers. So if you're building stuff with, let's say, C, or if you're using Java or something like that, you can just have one development environment with all your dependencies bundled in. You build, it's the same, I can give you my development environment, you can build as well, and you'll have the exact same end result that I have in mind, and there's no discrepancy between our systems. And you can do this with whatever operating system you like, so you can run Mac, Windows, and Linux, and you can be building on your operating system, I can be building on my operating system, and all we need to do is share our container, which defines our development environment, and then suddenly we have this shared ability to eliminate all these inconsistencies. It also means that it's good for QA, because you can have a standardized test environment, so that's kind of convenient. And finally as well, obviously, and this is where Docker's seeing, I guess, the majority of usage will be, it's good for production environments because it means that when you deploy, you can deploy on various kinds of AWS instances, and it doesn't matter the various restrictions that those instances have or the various differences in between them or hardware differences or whatever. That's all eliminated. It doesn't matter what the host operating system is. All of those differences are eliminated by the use of containers, and therefore you get this kind of consistency across your whole deployment environment as well. So I should say at this point, I am a developer. I'm not. And I also work in an R&D group, so I take things to a prototype level. So I can't really speak for test and production too much because we write really shoddy code, and then kind of like make it somebody else's problem later to go and fix it. So a container looks like this, sort of. You have your operating system kernel, so that might be a Windows kernel, a Mac kernel, or a Linux kernel. And then on top of it, you basically layer your container. And your container could be something pretty simple like this, which is running just BusyBox, or it could be something maybe a little bit more complicated where you start with maybe Debian, and then on top of that you add in Emacs, and then maybe on top of that you add in Apache. And in each instance here, what you're doing is you're creating a new image, and this is something that's not just unique to Docker, it's kind of across all kinds of containers. What you do is you start with your base layer, let's say Debian, and then when you add in Emacs, it creates a diff between the base layer and the new layer. And so the diff is basically part of this union file system idea, which is kind of a new concept. And the whole idea is you start with your base layer, and then you only store the delta basically between each image layer as you go up, and that kind of means that you minimize the amount of storage that you're going to want to, that you need to use in order to run the container or even store the container on disk. It means as well that if you wanted to run a raw Debian image, a Debian plus Emacs image, and let's say a Debian plus Emacs and Apache image, if you wanted to run all three of those together for various different reasons, I don't know why, you'd only have to store one instance of each of these layers. You'd have to store your base Debian layer, your diff layer for Emacs, and your diff layer for Apache. And containers will take care of the rest with the union file system. So, yeah, so I guess three advantages of containers. They're lightweight, in the sense that there's no hypervisor at the operating system layer. So you've pretty fast boot times. If you boot a VM operating system, it's like booting Windows, it's like booting Mac or Linux. You have to wait for the thing to come up. It could take a minute depending on the hardware you're running. With Docker, you more or less have instant startup because your application immediately gets wired into the operating system kernel that's already running in the host operating system, which means that it can talk to resources. It has access to everything immediately. So it's low latency. Also, as I mentioned, you have this layered file system, which means you can share common files between images and store just the deltas as you build up, and that minimizes your disk usage. Containers are secure, or at least we're told that they're secure. So the idea is that if you have a container, it runs in a special section of the operating system kernel, which means that it's separate from where other containers or applications are, and that basically is ring-fenced from the rest of your environment. And the idea is that if something goes wrong inside the container, that generally won't leak out into other. Now, it's not necessarily true in practice, but we're told that it's true. I'll maybe talk about one or two gotchas at the end of this. And then finally, containers are open. So everything that I've been talking about so far, Dockers and containers, Docker is based on LXC, which stands for Linux containers. So that's a GPL BSD sort of hybrid project. It's got full support in the Linux kernel. It's open, totally open standard. Docker is built on top of it. And as a result, this means that if you want to use containers somewhere, you have your choice of how you're going to deploy them. So you can use something like Docker to deploy them, or you can use something like Rocket, which is kind of like an alternative to Docker. It's kind of gaining popularity for various different reasons. I might talk about some of those in a minute. So to differentiate, Docker is a container platform. Containers are just the underlying technology that enables Docker. So Docker is backed by a company called Docker, and the company basically creates a number of different sub-projects. So some of these projects would be, the most popular ones would be Docker Engine, Docker Compose, and Docker Registry. And then other projects by Docker, more commercial, they're geared towards enterprise support. So it kind of works in a freemium model, a bit like how Canonical sells Ubuntu, that kind of thing. So the core Docker Engine project allows you to create and run new containers. It allows you to kind of like pull and run existing containers. So there's a Docker hub online. It's much like an operating system package repository. So if you want to go and run Postgres, you can say, hey, I'm going to pull that from Docker Hub, and then suddenly, hey, you've got a database running live. So I'll show you maybe an example of how that works in a minute. Docker allows you to manage data storage within your containers. So obviously, if you're starting from this Docker image, let's say your Debian with your Emacs and your Apache, great. But what happens when you start putting mutable data into your container? How do you manage that? Well, Docker basically makes all that very, very simple. Docker also virtualizes the networking between containers, so you can start layering containers on top of containers, building complex multi-tier applications, which are all with all these interconnections. And basically, you can create a virtualized network of what are essentially virtual machines, or what in effect work like virtual machines, but essentially are just containers running in your local environment, but act as if they're a virtualized network. Finally, you can do other fancy things like monitor your resources that your containers are using and collecting, redirecting logs, that kind of stuff. So if you're using maybe some sort of stack for monitoring your logs and processing your logs, there are a whole host of plugins for Docker where you can just automatically route all that stuff into your log processing tool, run your analytics on it, get alerts, all this kind of stuff. So that comes all built in just into one of their sub-projects, which is this Docker engine project. So the way that Docker builds containers is using a Dockerfile. So there's a pretty simple one here. All Dockerfiles have the same kind of start line. So you have to say, it's much like when you're writing a class of code, you have to say, I want to use some library or include some library. In Docker, you need to derive from an existing image. So here I'm deriving from Ubuntu 16.04. And maybe it's just a simple example. Maybe I just want to say hello world or hello CorkDev. So what I can do here is I can write a file with the 2-line contents there from Ubuntu 16.04, and then here I issue a command directive which just says what command I want to run when the container starts up. And that's it. Suddenly I can run this command here in the terminal window. I can say docker build, T for tag, call my container hello world, and then I can run the hello world container and it'll print out into my terminal hello world. So it's pretty simple. Things will get a little bit more complicated in a bit. So Docker Hub, as I mentioned earlier, it's this online repository of containerized applications. So this is stuff that other projects have gone out and they've taken their software and containerized it for you, so you don't have to do this from scratch. There's even a Hello World application. That's not it, the one I showed you. They have a fancier one. Generally speaking, the images are free and they're usually open source, which means you can go and open up their Docker files, take a look inside, see how the mechanics of what's, how everything's glued together. And there's a huge selection. So you can pull things like a whole Ubuntu operating system, Alpine Linux, Nginx, Redis, Node, Mongo, and there's loads more. There's a whole. So if you go to Docker Hub, hub.docker.com, there's a whole search engine built into it as well. So you can search for whatever application it is that you want. Also, it is free to sign up and contribute your own images. So if that's something you were interested in doing, hey. And finally, you can automate image builds as well from let's say, if you have code in GitHub or Bitbucket, you can just trigger with webhooks basically to have those built automatically and push to Docker Hub then, and then you can pull them from Docker Hub as well. So it kind of integrates nicely into production style pipelines. So Docker Engine makes it easy to download stuff from the Docker Hub. So as I said earlier, if you wanted to pull a Postgres database, you'd only need to do something as complicated as what I've got written here. So essentially what I'm doing is I'm calling docker run, which is the standard way you run a container. I'm going to do a port map from 5432 to 5432 on my local host. So 5432 is your standard Postgres port. Here I'm going to pass in an environment variable just to make things extremely verbose. So I can set my password to whatever my password is, and then I can run my container with whatever version of the application is that I'm looking for. And if you go onto the Docker Hub, you can see that there's a whole list of these containers and the various supported versions as well. And as soon as I pipe this into my terminal and hit enter, Docker will go, it'll do all the stuff in the background, it'll talk to Docker Hub, it'll pull the image, it'll map the ports, and then suddenly I'll have a database running in a matter of seconds, and I can talk to it using my application. So if you're building something with a REST API, if you're building something where you need to have a database, this is really, really handy and convenient for testing, because it means you can swap out different databases on the fly really, really quickly just by doing port mapping. And you don't need to go through the horrendously nasty install process of some databases, and this kind of just works straight out of the box. Again, you can do stuff like you can run Jenkins if you wanted to build your own build system. You can do, it's exactly the same thing. Docker run, you do a port map the Jenkins port to your local port at 8080. And then, as I said earlier, Docker helps you manage the state of your application inside the container. So if your application is creating some sort of mutable or persistent state, you can back that up to wherever you want. So if you have something defined, some directory defined under your backup environment variable on your host operating system, you can map that in here to var Jenkins home, which is the standard Jenkins state directory. And if you're wondering, like, oh, how would I know to even do that? Well, you can go onto the Docker Hub webpage for Jenkins, take a look, and it'll tell you all the instructions on how to back up the state from inside Jenkins. what ports Jenkins talks on, all this kind of stuff. So the documentation is actually, the containers are all self-documented, and it's reasonably quite good on some of the more mainstream ones. So I guess the message here is that there's no install. I say no setup, but obviously you're gonna have to do port mapping and maybe some environment variables or whatever, and then you just run, and it works. One of the other things you can do is you can run Docker in Docker, and things get kind of very Inception-like. So this is basically, you can go as many layers deep as you like. And the reason that you might want to do something like that is that if you have some build environment, let's say with Jenkins, you can put Docker inside your Jenkins container. So now you're running Jenkins in a container, you've got Docker in a container, and then you can run build jobs in Jenkins to build Docker containers from inside a Docker container running on your host operating system. Now, I realize that I've said the word container there about 400 times in one sentence, so sorry, but I'm assuming I've not lost anyone yet. You're all kind of looking vaguely amused because I've got Exhibit up here and no one's seen him in 10 years. So you can also, so as I mentioned at the start, there's a couple of different kind of top-level sub-projects, Docker Engine being one of them, Docker Hub being another one, Docker Registry, which is kind of like your own local version of a hub, and Docker Compose. Compose is basically a tool for deploying and managing multi-container applications. So just like your Docker engine helps you manage single container applications and administer and control volumes and data volumes, let's say state persistence and networking links in single containers, Compose does this for multiple containers. So I'll get into a little bit more about how that works in a bit. But just to say, maybe you're wondering why would you run multiple containers? Well, let's say if you want a blog, you might run MySQL and you might couple that with WordPress. You can run that as two separate containers, and you can bind the two containers together, and then suddenly you've got a blog just in two containers. You can do this in about 10 seconds. It's very, very nice. You could take something like Gogs, which is an open source Git repository. So this is something we actually do at Johnson Controls. We have Gogs, we've got Jenkins, we've got Nginx set up to wrap the two of them. So you get this unified kind of look and feel to how everything works. That's a 3-container application. That's all running on one machine, but it looks like, you know, it's 3 servers, essentially 3 containers is 3 virtual machines, sort of. But using Nginx, you can make it look to the outside world like it's just one. So that's the advantage there. And then finally, you might do something like you might have an analytics pipeline running maybe Postgres with MQTT, Apache Spark in there, and again, you might render your user interface using Nginx as a web server, and that's 4 containers. And again, very, very simple. The whole thing's up and running in a matter of seconds. Now, that's not to say that the stuff that you're putting in there is up and running in a matter of seconds. That's your mileage may vary depending on what you're trying to do, but to actually get the architecture up and running is very, very simple. So Compose lets you build and run multiple services. You can specify dependencies in between your services as well. So if you have a REST API and you've got a database, you can say, hey, this REST API needs this database to be available before it can be of use to anybody. And Docker is smart enough then to start the database first, start the REST API second. There's a few caveats to that, but essentially that is how it works. Again, it does all the things that the Docker engine does, but it just does it at scale for multiple containers at a time. So just like Docker engine can help you monitor the status and the resource usage of, let's say, a single container, Compose lets you do this for many, many containers all in one go. Again, you can manage state, so your data persistence, you can manage this for multiple services all at one time. And again, you can aggregate all your application logs and so on, and much more. I'm only skimming the surface here. If you wanted to go about building a multi-container application, it's not that difficult. There's only 3 steps to it. For each custom service that you're going to build, so a custom service might be, let's say, you're running a web server, but you've got some bespoke content that you've written yourself that you want to put into that web server. That's a custom service because you're taking something that exists, but then modifying it for your own uses. So for each custom service, you're going to want a Dockerfile. So that's that thing that I showed you earlier. You have your top line, which says from some existing container that you're going to derive it from, and then some additional instructions where you customize the contents of the container to do exactly what you want to do. Number 2, you're going to have to define all of the services that you need using a YAML file, which is usually called docker compose.yaml. It looks a bit like this. So this is a kind of an example application here, 2-container application with they changed the kind of format of the YAML file about 6 or 8 months ago. So now all the new YAML files have version 2 at the top, but you can kind of discount that. The important bit here basically is the services tag, and down here you've got a volumes tag. Inside here you've got my app with some configuration for my app, and you've got a Redis container down here with some configuration here. And then finally you've got your volume section down here, and you've got my app data, and then I've got some empty curly brackets. So this all probably looks like double Dutch. It's not that bad. Essentially what I'm doing here is, I'll start at the bottom. I have a volume. I'm going to create some data volumes. I'm going to create one, let's say, for my app. I'm going to call up my app data. And by just leaving that blank, I'm going to leave all of the configuration up to Docker on how to do the nuts and bolts of the state management there. The built-in state managers, data volume persistence is pretty good. But again, as I mentioned, Docker kind of works in a plugin type system. So what you could do if you wanted to is you can put in some extra fields here, and you can have this persist all of your state of your application to Amazon S3. And that just works out of the box. You just give it, say, the flavor of data storage I want is S3. Here are my credentials, my IAM credentials, and job done. It's going to just seamlessly map part of your container file system onto S3. Your application is just going to look at it like it's a local disk. Everything will work out of the box. Inside in your services then, you have two services, one for my app and one for Redis. Redis is just going to, when I say image Redis, that means I'm telling Compose that the image that I want to run is just the standard Redis image, which is up in Docker Hub, so it'll go and pull that down for me. And then here, I'm just telling it I'm going to build something in my local directory. I'm going to link it to Redis, which means I'm going to create a network link onto the Redis container. It means I can reference Redis as Redis inside here. So instead of having to say localhost or do a lookup or pass in environment variables telling you what the name of my Redis server is or anything like that, it's just Redis. It's always going to be Redis because Docker has just set it up that way. If you change this to something else, you can say, I want to call my Redis container my Redis container or something, and you can do that too. But essentially, all of this initial environment setup is just defined in one file. Finally, then you can do port mapping. So you can map, let's say, port 8080 of the container onto your local host port 80, because the container is itself a virtual machine. And that means your port 80 on your host operating system becomes port 8080 in the container. So if someone hits your host operating system on port 80, it gets seamlessly routed through to the container through virtualized networking, and everything just looks and feels like it's running on your local operating system, whereas in fact running in this isolated sandbox container. And then finally here, I've got some, as I mentioned, I created a Docker volume down here, and maybe I have some state here in varlib my app directory, and I want to map that back into my app data, which means that every time I create new stuff inside in this directory here, when I'm running my application, it automatically gets copied in here. And then if I want to do a backup job or something, I can run a backup job really easy. I just tell Docker, back up this my app data folder, stick it on S3, stick it somewhere, wherever it is you want it, stick it, and that's it, it just works. And then finally, once you've got this file written, all you need to do is run docker compose up. It'll parse the YAML file, it'll say, I need to pull down Redis, so it'll go to Docker Hub, it'll pull down Redis, you'll see the progress bar. It'll say, I need to build the app locally, so it'll initiate a build job on your local app, it'll look for a Docker file, which tells it what to do. So if you have some compilation instructions or something, that those might be inside the Docker file, it builds your application, boots the containers, does the networking, maps out the data volumes, and suddenly your application is running live, mapped to port 80 on your local operating system. That was a lot, I understand. So does anyone have any questions at this point? Have I lost everybody? Okay, so either everyone's being really polite or I've lost everybody. So some gotchas and limitations. So right now, Docker is supported on Mac, Windows, and Linux. That's a relatively new feature. Up until recently, it was predominantly just a Linux thing. There are some restrictions. If you have a Mac that's older than 2010, you probably don't, but you can't run Docker if you do. If you have a pretty new Mac, you're fine. It only works in Windows 10 64-bit as well, but lots of Linux distributions are supported. Now, not everyone is, but all the big names will be. One that actually isn't is BSD. So any kind of free BSD-based operating system is not supported, which means as well, and that works both ways, it means that you can't use a free BSD-based operating system as your host OS, but also you can't use it as your container operating system either, which means you've got no Mac OS containers and no BSD containers. But there are Windows Server and various different Linux flavor operating system containers. Just some, if you are going to go about using this in Again, as I said, I only use this for kind of like developing and testing, not really for production. Some stuff that I've run into myself is that if you use the Docker engine, or if you're using Docker in general, it relies on a daemon process that's running on your host operating system. If the daemon dies, everything's gone. So it doesn't mean that all your state is wiped or anything like that. It probably will all still be there, but all your containers will stop. So if you're running a whole host of different services, everything's just going to go down at once. If there's a seg fault or something in the Docker daemon that's just not well written, if there's a bug in there, everything's nuked. If you want to, you can use something like Rocket. So I mentioned this earlier. It's a kind of an alternative to Docker. It doesn't have any of the volume management or virtualized networking. None of that stuff comes with it. But it does run basically separate processes for each container. So if one Rocket process dies, another one won't. So if you're kind of paranoid about everything staying up all the time, then maybe Rocket is the way to go. Otherwise, Docker is pretty good. I've not tried it, but I'm guessing yes. Yeah, because they're both using Linux containers. It's not a question of running Docker and Rocket. It's just a question of running Linux containers in Linux containers, which is possible. So I'm going to say yes, but I'm. Yeah, it's a good point actually. Yeah, just to have the extra layer. Yeah. Can I join your startup after this talk? So containers basically as well are, as I said, they're kind of touted as being this like totally secure, isolated island environment where you can do what you want and there's no consequences for anybody. And as with any simplification, it doesn't really quite work out that way. Containers generally are only really as secure as you make them. So by default, everything runs as root inside the container. So if you pull a Ubuntu container, you're running it. You're running by root as default. Now that doesn't mean that it's running as root in the host operating system, but it does mean that if again there's a bug in that single point of failure in the Docker daemon, what can happen is that from inside your container, you might reach back up into the host operating system if you've not been very careful about how you set up your containers. To be fair, you do need to go out of your way to kind of screw yourself, but you could compromise the security of your host operating system if you were to run this in a kind of sloppy way. And again, if there's a security bug in the Docker daemon as well, to date there hasn't been any major ones, but they are fixing bugs and they do have a kind of a reporting structure. So if you do go down this road and they do identify that there's this massive bug, a security hole, it could compromise everything because again, there is that single point of failure. Right, so that's Docker. So that's 1/3 of the talk. You're gonna be here till, I'm kidding. The rest of it's reasonably not as long. So InfluxDB, which is the second buzzword that I mentioned at the start. InfluxDB basically is a time series database. So this would be a little bit different to maybe databases. Just out of interest, has anybody used InfluxDB? Nope, cool, okay. So it's a time series database. It's developed by InfluxData, it's open source. And the whole purpose of them developing this, as opposed to a standard SQL database, so it's a NoSQL database, not only SQL, is they're looking basically for just storing time series data. So they're not interested in storing big JSON blobs. They're not interested in storing geographic data or images or anything like that. They only want to store metric data with timestamps. I'll give you an example of what that looks like in a second. So the whole purpose of this basically is to provide really, really fast querying. Your data is available supposedly within 100 milliseconds of you doing an insert statement. It supports about 100,000 writes a second. There's additional support for high availability. It's not enabled by default, but you can do this if you wanted to. And also, the whole architecture is extensible, and I'll talk about how that works as well a little bit. And then finally, everything's done over HTTP. So if you want to interact with the database at all, you don't need to get your own client. You can if you want to, but if you want to just interact by HTTP, that's enabled by default. And then there's clients in loads and loads of different languages like Go, Java, JavaScript, Python, Ruby. There are only a few. There's actually like a whole like I know there's like 30 or 40 of these, so it's actually pretty popular. Data is ingested via what they call the line protocol. So this is the line protocol here, it's what it looks like. So measurements there in orange, they define your kind of data collection. So a measurement would be kind of like a table. A tag then stores labels. So if you want to label some data, you can attach a tag to it. Fields then store your values. So that's your actual raw metric values. So those can be basically 64-bit integers, 64-bit floating point numbers, strings and booleans. And data then, when you do an insert, you always associate data with a timestamp, which is this guy here in red, and that's measured in kind of nanoseconds from 1970. And then basically, as soon as you do your insert, InfluxDB will index the data by the tags and by the timestamp. So you can do really, really fast lookups here without having to go off and create your custom indices or queries or whatever. So once your data gets in, you can get it back really quickly. Other ingestion protocols are supported. So InfluxDB kind of came from the idea of this thing called Graphite, which I don't know if anyone's used here, but it's another time series metric storage database. It's in the next generation above Graphite. People tend to be drifting away from Graphite, but if you do have Graphite and if you're relying on Graphite, what you can do is you can just do a hot swap for InfluxDB and just put in a little adapter in the middle, which is their plugin for Graphite, and that means that your existing application, which talks to Graphite, can still think like it's talking to Graphite, but actually all that gets converted on the fly and it gets stuck into InfluxDB instead. So Influx uses something called InfluxQL. It's a SQL-like language, but it's focused on time series, manipulation, aggregation, that kind of stuff. So you get your standard basic SQL type queries. You can do selects, wheres, group bys, whatever. You've got some aggregations in there, so you can do counts. You can find out the number of unique elements. You can do things like mean, median, sums. You can do selectors, stuff like first, last, min, max, percentile. You can do transforms as well, so you can do like really, really fancy things here, like histograms and moving averages. And then finally, you can do things like prediction with Holt-Winters. Holt-Winters is like an exponential smoothing algorithm. It was only just recently introduced, so I guess if you're looking for a trajectory for the database, they're looking to get more analytics into it over time. That is the direction they're going in. So Holt-Winters is kind of like the first stab at it. Right now, it's really awful, and I'll show you in a while how awful it is, but it's pretty awful, but it will get better in time. Everything else works really, really nicely, I should say. And again, if you're like materialized views, you can do this as well. You can do something like what's called a continuous query. It gets you something that looks it's kind of like their equivalent of materialized views. And then finally, as I mentioned earlier, the whole database is extensible. So Influx also have this separate product called Capacitor. Again, it's open source, but they're selling enterprise support for it. And it allows you to do things like anomaly detection with static thresholds. It allows you to create alerts. So you can alert to a log file. You might run a HTTP post when something goes wrong. Send an email. You could do Slack, whatever. And then finally, probably the coolest thing for me, because I work in analytics, you can write your own Python functions and run them on the database directly. So, and then if you wrap that in something like a continuous query, you get your materialized view. It's basically your output of your analytics function, and suddenly you've got a whole analytics system all in one package. So that's quite nice. Now, is it as good as something like Spark? Who knows, but it's still cool to be able to go and do stuff like this. So Grafana then is the dashboarding utility. So InfluxDB basically, it's just for data storage and querying and manipulation. It doesn't give you any fancy graphics. So this is where Grafana comes in. So this is what a Grafana dashboard might look like. I got this from their website. For some reason, they've repeated various subpanels. But anyway, you kind of get the idea of what you can do with it. All these things are basically metrics that you have in some database. You're going to pull those metrics out and basically plot them. You can you can annotate your plots. You can create various kinds of visualizations. There's kind of like bar charts and histograms and line plots, these fills as well. So it's got some nice features. It's really just focused on viewing the graphics, viewing the data, creating graphics from data. And everything is interactive. You can zoom with your mouse and whatever. I actually will be showing you in a while, assuming that you're all still here at the end of my talk. So dashboards are highly customizable. So you start out with basically rows. So that will be a row there. You have a second row there and a third row there. And then you have panels, and so you have two panels there in the top row, you've got one in the middle row, and again, two in the bottom row here. So everything is adjustable. You can drag and drop and whatever. You can create your own dashboard for your specific application that you want to monitor, whatever it is you want to be doing. You can tag your dashboards, make them searchable. Really, really interestingly, you can template them. So if you come up with something, if you create a dashboard for monitoring your Apache server, you can then, if you're running 10 Apache servers, you just build one dashboard, you template it with a variable, and then suddenly you scale it, and you've got 10 dashboards, one for each server, but you've only got one set of source code backing it. Dashboards are all written in JSON as well, so you can create them visually, or you can code them manually if you prefer. The GUI is quite good for doing it. And then once you're done, you can just basically save all that JSON out to a file, and then distribute it around your organization. Everyone can use the same dashboard. And then as well at grafana.net, where you can find Grafana. There is a repository of existing dashboards that people have made for various different applications or combinations of applications that are kind of commonly used together. So with panels as well, there's a huge selection of panels. So you can get time series, you can get pie charts. You can get something more fancy here. It's like a box plot with time series graph overlaid on it. You can just get, numeric metric indicators. You can do some fancy stuff with graphing down there as well. And again, much like dashboards, panels can be templated and automatically generated for groups of metrics at a time. So you can just build one panel, scale it out, and then suddenly all your metrics are represented kind of like in a very consistent manner across your organization. Again, panels can be exported as JSON, and crucially as well, you can actually just take a panel, click and it say share, and you can get a URL, an anonymous URL. You can post that to someone in your team. They don't need any access rights to your Grafana, and they can see what's going on. They can click and drag and zoom in and get a feel for what's going on. So if you want to create a bug report, it's really, really nice for that kind of stuff. You attach a Grafana URL in there, and they can only see, let's say, something goes wrong here in the middle panel. I could click share. It'll just take that middle panel. I can send it to you in an email. You'll get a URL. You click through. You get my Grafana interface, but you only see the one panel that I've shared with you with certain time bounds on it, and then you can clearly see what the problem is. You can zoom and you can do all your data exploration on the fly. So Grafana doesn't just work with InfluxDB, it works with lots of different databases. So Graphite, that I mentioned earlier, works with Graphite. It works with Elasticsearch, works with CloudWatch, Prometheus. Some people, if you're in DevOps, you might be using Prometheus. Prometheus is more or less designed to work with Grafana anyway. But again, if you have a data source, and in Johnson Controls we do, so we're looking at this at the moment, if you have a data source that isn't designed to work with Grafana, you can write your own plugin, and you can make those two things talk together. So the whole ecosystem here is totally open and customizable. So you might remember many, many eons ago, I promised to build an analytics dashboard in 150 lines of code. So it's 112, fingers crossed. So using Docker Compose, InfluxDB, and Grafana, I'm going to seamlessly knit it all together and create an analytics dashboard. So the structure of the project looks a little bit like this, right? You have a configuration.env file. It's just going to store environment variables that are going to be shared commonly across all the services that we have. You have your Docker Compose YAML file. So that defines basically how the services are orchestrated, what the various volume mappings are, how they're linked together, how all that networking is virtualized. And then we're going to have an InfluxDB container and a Grafana container. And each one of those is defined by a Docker file. And there's a kind of a design pattern for Dockerfiles that uses an entry point script. And I'll explain how that works in a second, using the same design pattern down here, a Docker file and an entry point script. And then finally, I have a data sources directory and a dashboards directory. I have a default data source, which is going to be InfluxDB. So when you run the application, it's going to start InfluxDB, it's going to start Grafana, going to network the two of them together. It's going to tell Grafana to look at InfluxDB, log into it, and then from nothing, you'll be able to start creating dashboards. And then finally, once you're done, if you want to come back around, you can save out your JSON dashboards, pop them in here, rebuild the application, and share it with as many people in your organization that you want. And they'll have the same dashboards as you did out of the box. So some things we need to do. We need to make Grafana aware of InfluxDB. Then we need to be able to grant Grafana access to InfluxDB. And then, as I said, it'd be nice if we could kind of like load up some default dashboards as well out of the box. So the configuration file is literally just environment variables. So it's like standard Linux environment variables. So I have some stuff for Grafana up here, some stuff for InfluxDB down here. You might be wondering, where did I come up with the environment variables from? You can find them in the documentation. So both InfluxDB and Grafana they're very, very well documented, and there's big long lists of environment variables, what they do and what they can be used for. These applications are intended to be Dockerized effectively. And Docker relies on environment variables for configuration. So here I might, by the way, I will show you a live demo. I haven't used these credentials in the live demo, so if anyone thinks they're going to be smart, I've taught you already. And finally down here, you have InfluxDB user, InfluxDB password, and whatever your Influx database is going to be called, your standard, the default one that we're going to create for our analytics dashboard. So the next thing we're going to do is create a Docker Compose YAML file. So again, like I said earlier, we're going to use version 2 because that's the standard version now. We have a services section and we have a volume section. The volume section basically handles all our data persistence. So we're going to create a volume for Grafana to persist all the state from Grafana. create a volume from InfluxDB to store all the state from InfluxDB, so the entire database state is going to be persisted to that volume. And then inside in the services section, we have a service for InfluxDB, a service for Grafana. With InfluxDB, we just say there's a folder called InfluxDB. There's going to be a Docker file inside that folder, so you're going to build everything in there. You're going to set all the environment variables that we define in our configuration file into the container itself. So if you're inside in the container in a shell, if you type echo that environment variable, you will see exactly what is inside that configuration file. And then you're going to map varlib InfluxDB to your Influx data container, or sorry, volume, which is defined down here. Similarly, with Grafana, it's the same thing. So you're going to build whatever's in the Grafana folder. Again, you're going to use the same configuration environment file. You're going to link it to InfluxDB, and you're also going to call InfluxDB InfluxDB, which means that inside, if you say ping InfluxDB, the host file, you'll see if you go into your Grafana container, you'll see that the host file is automatically populated with InfluxDB and the IP address, and that's already done by Docker. That's just by this one line here. Finally, you're going to map out the ports so you can access Grafana at your local host, and you're going to do some backup of your Grafana data as well into the data volume that we created for it. So that's a lot in one slide, but there's a kind of pattern to this, right? So it's the same kind of stuff that you're doing with both services. It's the same procedure, basically, every time you create a new service. So back to Dockerfiles. So this time, instead of deriving one from Ubuntu, we can just derive one from InfluxDB, which is on Docker Hub. All you have to do is, after the colon, you just specify the version that you want. This one happens to run on Alpine Linux, which means it's nice and small. It's pretty simple. You just create in /app. Alpine Linux as well is, sorry, I should say, Alpine is Linux. So everything in here is going to work like in Linux. It's not Windows. So we're going to create a work directory in /app, copy this entry point script that I've been telling you about, copy that into /app, make sure we can run it. And then finally, we're going to set the entry point of the container to be app entry point. An entry point basically is the initial action the container will create. So as soon as the container starts, it's going to hit the entry point, and that defines how it's going to behave next. So whatever is inside in the script basically tells the container how to work. And if you realize, when you look at this, all we've done here is say, the container is based on InfluxDB, and then everything after that point is just saying, well, just start the entry point script when the container boots. So that's the pattern. So, whoops, gone one too far there. I'm sure you're all delighted to know. So the entry point script basically, it defines how the container works, and it's actually not that bad. I know if you're not a bash programmer, this looks like the worst thing in the world. It's not too bad. Basically, what it's doing is there's an if statement up here. It just checks to see if a particular file exists. If it does, then we do all this stuff in here. Otherwise, we're just going to start InfluxDB the standard way. If the file doesn't exist, then we go inside the if statement. The first thing we do is we start InfluxDB. The next thing we do is we just wait for it to start up, which basically means we just hit this endpoint and wait till the endpoint exists. Once the endpoint exists, we know the API is up, and then we can start interacting with it. Then we can set our InfluxDB user and password. Those are set in the configuration environment file from earlier on. Finally, we touch the file just to make sure that it's there for next time, so that if we shut down the container, start it back up again, that we don't have to do all this stuff again. And then finally, we go hit InfluxDB. So with Grafana, it's pretty similar. The Grafana image is based on Ubuntu. So Influx is based on Alpine. This is based on Ubuntu. So just a little bit of configuration. So we start from Grafana, from the Docker Hub, installing curl and get text base, because I need those later. We're going to make the assumption that we have some dashboards to copy in. Initially, we don't, but I'll show you some that I have later. And then finally, we copy in data sources. So we've got that default data source that we want, basically, that defines our connection to InfluxDB, gets us logged in, and gets us everything up and running. And then below that point, everything is identical. It's the same entry point pattern that you saw from before with the InfluxDB container, which means basically we have an entry point for InfluxDB, we have a separate entry point for Grafana, and as soon as we start this Grafana container, it's going to hit the entry point script, figure out how it's going to run. And again, it's the same pattern inside here. It's just waiting for an it file, comes in, it starts Grafana, it waits until the API is up, and then it uses curl to push each data source into the API and push each dashboard into the API. Now initially, when you start this, there won't be any dashboards because it's just a minimal application. But if you create dashboards, export them as JSON, save them back into the dashboard directory, rebuild the image, the next time the image starts up, you'll get all your dashboards loaded up as well. And this is the magic of how it all works. So your default data source, you basically, all these environment variables here are available within the container. And when back here, I'm calling env subst, or environment substitute, which basically means that before I push all of this JSON blob to the UI, sorry, not the UI, the API, I'm just running it quickly through the environment substitute program first, which means that if any of these environment variables exist in the host operating system, they get subbed in automatically. And because they exist in the configuration file, we've mapped the configuration file using the Docker compose YAML file, all this stuff gets nicely substituted before it hits the API. And so you get auto configuration of InfluxDB in your Grafana container. So, who's still with me? I feel like I've worn out my welcome. Okay, so basically, that's the structure, and what this gets you is a really, really ultra minimal dashboard. It gets you a database, and it gets you a Grafana dashboard basically that talks to that database automatically. So the whole thing, once you run your Docker compose up command here with this project structure, you get your database and you get your dashboard, and your dashboard's mapped back to your local host. You can hit your own browser, Firefox or Chrome or whatever, and you can see your Grafana interface. Now, one thing I haven't talked about is how to get data in here. So rather than bringing everybody to tears and showing you all the Python scripts I've created to get the data in, I'll just tell you that Cork City Council has got open data online. So you can go to data.corkcity.ie. And then basically it's very, very simple to write a Python script to scrape that website, and then using the InfluxDB Python library, it's one of the supported libraries, or supported platforms, I should say. It's really, really easy to pipe this data into the skeleton application that we've built once we run it, and to save out those dashboards, and that's exactly what I've done. So I'm going to attempt to show you this now live. Fingers crossed it's going to work. So this is Grafana in action. You start out, you have a home dashboard. There's not much in it. I haven't really put anything in it. But if you want, you can have various links and searches and whatever else. It's basically your home screen. So if you're a DevOps engineer, maybe you're going to populate this with handy, convenient links to whatever dashboards you might want to look at the most. What I've done here is I just put in the forecast link, a map link, and an overview link. So if I hit overview here, this is all streaming off my phone, so hopefully it'll work. Yep, cool. So what you can see basically is live car parking data from in a dashboard format for all the various different car parks in Cork. So right now Merchants Quay is at 42% capacity, St. Finbarr's is at 40. You can define these gauges. If you want, you can change the coloring scheme here for the gauges. I've just set it arbitrarily. Down here on the bottom, what you can see is time series data for all these car parks today. And just to demonstrate maybe some of the features, so what I can do here is, if I'm interested, I can just click and zoom. Not much has gone on. It's pretty flat, as you can see. What I can do is, if I go up to the top here, I can say, give me the last 30 days. So you can see even more data. Now, it's flat back here because the City Council did something to sabotage my live demo a few weeks ago. But yeah, so what you can see basically is you've got the whole history of Cork parking. So it's a view into how a city works, and you've got this in one dashboard. It's really, really nice. It's really cool. By the way, if anybody wants the data, I have this going back to last February, because I've been planning on doing this for ages, and it was only when James said it to me that I finally got spurred into action. So if there's any data scientists in the audience who want I can give you loads of data. So that's only one possible dashboard. We've also got others. So I'm going to jump back here to overview, go into the map view. So as I said, there's like a whole load of different panels that you can put into your Grafana dashboard. So a map view is another one. So I get this really, really nice interactive map, which shows me green circles, just indicating various different car parks around the city. Right down there at the bottom, you've got Black Ash. And if I hover over, I can see Grand Parade's at 82.95% apparently. And so I get I can zoom out here as well. So if you another 10 potential application of this as well is that if you have services running in multiple different AWS environments, you can geotag those. You can have those in a map. You can see which availability zones are up, which ones are down. Map it to, are your failure, an immediate visual indicator of whether all your failures are happening in a specific geographic region. That might be convenient. Help you kind of find a root cause faster. And then finally, I mentioned earlier this kind of halt winters. So what I was hoping to be able to do is to be able to accurately predict into the future based on previous behavior what the future capacity of a car park might be, because I had this I don't own a car, by the way. I have no vested interest in this whatsoever. I thought it might be really, really interesting if you had an app for your phone where you could say, you know where I am from my GPS. I'm heading into Cork City now. Just tell me what car park to drive to that I can guarantee a car parking space in because it's, rush hour, it's 9 o'clock in the morning or something. As you can see, it's not great. Now, there's a whole lot of reasons that it isn't great, but mainly they are to do with the way that this is coded on the InfluxDB side of things. Some of it is to do with the fact that the data is pretty crummy as well in places, but InfluxDB support for predictive analytics is at the moment not the most mature. It's a new feature. It only came in the last 3 to 6 months. They are planning on implementing more, and they are planning on hopefully making this a little bit better. Right now, it's just a matter of resolution. The whole thing's just not very stable, but you get the idea in principle. So I just be glad to know I'm about to finish up. So a brief, and I still use them with irony, a brief introduction to Docker, InfluxDB, and Grafana. I want to say it's easy to create multi-container services. It's good for learning, it's good for development, it's good for testing, good for production, although I can't really vouch for that last bit. And complex analytic systems as well, they're becoming easier to use all the time and simpler to use, and the integration as well is becoming much, much easier. And the key idea here is that it should be usable by non-experts really, really quickly and really easily. But as you've seen, it's not quite fully there yet, but we'll get there eventually. And finally as well, the Cork parking dashboard, it's live for now as long as my AWS account can support it. Please don't DDoS me. You can find it at parking.donagh.io. And if you want the GitHub code for all of this, it's up on GitHub as well. It's under GPL3. If you want it under a different license, send me an email. So that's it. Thanks very much. Any questions?